You've seen it in the movies 1,000 times, right? The heroes in an elevator, the lights start to flicker, you hear that awful snap, and the whole thing just plummets. It's a classic scene, and it's absolutely terrifying. But what if I told you that whole scenario is pretty much pure fiction? So let's just ask the big question, the one you probably thought about while standing in a little metal box suspended hundreds of feet in the air. What really happens if those giant steel cables actually break? Well, the answer isn't a terrifying free fall. It's actually a story about some truly brilliant, life-saving engineering. Okay, so the first thing you have to wrap your head around is the whole philosophy behind modern elevator safety. It's not about making a system that can never, ever fail. Instead, it's about designing a system that when something does go wrong, it automatically defaults to a safe state. It's an incredible concept called a fail-safe design. Now, that word inherently is the key here. It means safety isn't some extra feature that has to be turned on. It's the elevator's natural state of being. The system isn't trying to be safe when things break. It's built so that its default powerless condition is the safe one. And this quote just explains it perfectly. Think about the brakes in your car for a sec. You have to actively push the pedal to make them work. Well, elevator brakes are the complete opposite. They are always on, clamped down hard. The only thing holding those powerful brakes open is the tension from the cables holding the car up. So you see where this is going. If the cables snap, that tension instantly disappears and bam, the brakes slam shut all by themselves. But honestly, that whole snapped cable idea is kind of flawed right from the beginning. We all picture this single frayed rope giving way, but that's just not how elevators are built at all. A modern elevator isn't just hanging by a thread. Nope, it's being held up by a whole group of incredibly strong, totally independent steel cables. We're talking anywhere from 6 to 12 of them, and for some of those super tall skyscrapers, it can be even more. And here's the really crazy part. Every single one of those cables is over-engineered to be strong enough to hold the entire weight of a fully loaded car all by itself, with plenty of safety margin to spare. So for an elevator to actually fall, all 6 or 8 or 12 of these super robust cables would have to snap at the exact same time. The chances of that happening are, and this is putting it lightly, basically zero. But okay, let's play Hollywood's game for a minute. Let's say the impossible happens and every single cable breaks. Is that it? Game over? Not even close. Because that's when the elevator's real unsung hero kicks into gear. A simple, purely mechanical device called the overspeed governor. This is just beautiful, simple physics at work. See, there's this pulley at the top of the shaft that spins right along with the elevator car. If the car starts to fall, that pulley spins way too fast. And just like when you're on a merry-go-round that's going too fast and you feel pushed to the outside, little weighted arms inside the governor get flung outward by centrifugal force. If they fly out far enough, they physically trip a switch that grabs onto a separate rope, and that's what triggers the big emergency brakes. The best part? It needs zero electricity. It's pure mechanics. All right, so the governor has detected a free fall. It's tripped its switch. So what happens next? This is the grand finale, the final act that makes absolutely sure the elevator car stops dead in its tracks. The moment that governor rope gets grabbed, it pulls on a lever system right on the elevator car itself. This system forces huge, powerful brake shoes to slam into the steel guide rails that the elevator runs on. We're talking a massive amount of friction here, enough to bring the entire car to a stop, quickly but smoothly enough that it won't hurt the passengers. It just stops. And believe it or not, this isn't some new technology. The inventor, a guy named Elisha Otis, was so sure of his design that way back in 1854, he put on a show at the New York World's Fair. He stood on this open elevator platform, hoisted it high in the air, and then had a man publicly cut the only hoisting rope with an axe. The crowd gasped, the platform dropped, maybe a few inches, and then the safety brake kicked in and stopped it cold. That single demonstration is what gave people the confidence to build skyscrapers. So, you see, when you put all these pieces together, an elevator isn't just one system. It's a whole series of overlapping, redundant safety nets, all designed to make sure that even in a failure, the outcome is safe. So let's just quickly run through the layers again. You've got, first, a whole bunch of redundant steel cables, any one of which can hold the car. Then you have the overspeed governor, a mechanical watchdog that's always on alert. Below that, you have the fail-safe emergency brakes that are designed to slam shut without any power. And you know what? Even if all of that somehow failed, there are giant shock absorbers or buffers at the very bottom of the shaft just in case. So the next time you step into an elevator, maybe you can forget about those scary movie scenes. Instead, just take a second to think about the brilliant, multi-layered engineering that makes it one of the safest ways to travel on the planet. You're not just stepping into a box, you're stepping into an absolute marvel of fail-safe design.